All right, hey everyone. Thanks for coming out. I know it's getting toward the end of the week and everyone's probably feeling a little bit, but appreciate you coming out, and we're gonna have a good time and learn a little bit about chaos engineering today. So my name is Tyler. You can find me on both LinkedIn and Twitter. Probably won't get a chance for questions, and I know they sort of get people moving out fairly quickly afterwards, so happy to answer questions if there is time afterward, but the best way of getting in touch is definitely over those means. Actually, before we even get into chaos engineering, I wanted to talk a little bit about where I came up with my Twitter handle, which is Tyler. So at Audible, we like telling stories about everything. So I figured this is a good way to kind of kick off the talk, reset your brain a little bit since you've heard way too much about the more technical stuff over the course of the week, and hopefully give you a little reset as you're about to learn some more stuff too. Like I said, my handle is Tyler. That was basically the I chose it because it was the only word that I could find close to Tyler that was still available on Twitter. And it's basically the Latin genus or subgenus or something for the family of three-toed mammals that includes alpacas, guanacos, and llamas. So if you learned nothing else today, especially about chaos engineering, at least you've learned a fun llama fact. So share that with everybody and take that back from reInvent. But we're actually here today to talk about chaos engineering, right? And so like I said, we like to tell stories at Audible. It's kind of what we do for a living. Today we're going to tell you a little bit of a story about how we at Audible got into chaos engineering. Talk a little bit about an event that happened a little while in the past, what we learned from that event, and how it sort of led us down the path of chaos engineering. And what we learned along the way, and hopefully help you figure out the right path for you to get either into chaos engineering in the first place, or maybe even just a little bit more advanced with it if you're already doing it. We'll kind of start with talking a little bit about distributed architectures, how they lead to complexity, which eventually leads to chaos, which of course leads to the dark side. For anyone who caught the keynote this morning, I love the talk about S3 and just how massively complex that has gotten for something that you really, when you think about, or at least when I think about, really seems like one of the more kind of simple or like basic services for AWS. And they were talking about how they went from, I think they said 8 services, microservices, to somewhere over 250 since it's launched. And so I think a lot of organizations are probably in the same boat of that. We at Audible have definitely gone down a similar path. And as you start to get that complexity is where a lot of this chaos starts coming in. We'll talk about, like I said, a specific case of chaos at Audible, a case where we thought that we understood our systems very well, thought they were very bulletproof, very resilient, and of course, our customers found out for us that they were not. And then we'll walk through how to actually implement chaos engineering, what tools there are available, and what you'll be able to get out of it. So let's start with the most important thing. That's me. So I've been at Audible for a little over 7 years now. I manage our player experience team. It's the team that is responsible for basically really the main thing that you sort of think about if you're an Audible user, which is listening to books or any of our other audio content. We own the player itself on the iOS app, Android, the website, and then all of the backend services that power listening across all of the other devices and surfaces that we're on. I had started working at Audible on the website team. I've also managed directly a few of our services teams. So I've sort of been around the Audible world in terms of the different technologies that we use. And so I've seen the chaos that we've got there across all of it. So right now at Audible, my team is specifically working on extending our content delivery, making it more powerful globally, increasing the speed at which we're able to deliver our content, making it more reliable, of course, and that's where chaos engineering comes in, and bringing it to a multitude of new devices for our customers so that no matter where they want to listen, they have that power. We're also working consolidating our delivery and playback across all of these different surfaces, making it so that every time there's a new device we want to get to, it doesn't take quite so much work. We're working on improving our audio quality itself. And this is really important for us as we get into more original content and into non-traditional places like the living room or more high-quality audio systems than we've traditionally been on. We have been moving to more and more AWS services recently. We're focused a lot right now on serverless, like I'm sure 99% of you here are. We're definitely looking at some of the new things that were announced over the last couple of days, and we'll be taking those back. We're mostly using that around some of our event-based architectures. And then we've also been exploring some things like containers and Fargate. But for the most part, we're running on some of the more traditional things in AWS. Before we moved to AWS, back a little bit before I joined Audible, but it was still going on when I was there, was when we first started really moving on to AWS. So before that, we had been on our own set of internal data centers, probably a lot like a lot of your companies may be right now. And so that transformation for us is really where we started to focus a lot more on reliability and where we started to get a little bit more into chaos engineering. Those data centers that we used to be on, of course, were a lot less reliable, way costlier, much harder to manage. And so part of the reason that we even moved on to AWS in the first place was to get more of that reliability and have more ability to scale as we grew. And that brings us to really the meat of today's talk on how we're actually doing that. And before Audible, I worked in the financial industry on high-frequency trading systems, although nobody called it that then. I think the book Flash Boys was basically written about my team. I just didn't know it at the time. And so that was another place where we were obviously very interested in highly scalable and resilient systems, just sort of with a little bit of a different focus. And so my career has really been focused around these high-scale distributed systems, and specifically around the quality and resiliency of them. All right, so who here is actually familiar with Audible before they came to this talk? All right, good. That's what I thought. Usually, that's pretty much every hand. I love it. We're super happy that you know that. I think we've got a great brand recognition. Of all of you, how many have actually listened to, let's say, more than one book on Audible? All right, that's still almost everyone. That's great. So then I can skip all of that part. But for anyone who doesn't know, we're headquartered in Newark, New Jersey. We were founded back in 1995. That makes us a relative dinosaur in terms of technology companies, I think. That was before the iPhone, of course, even before the iPod came out. We were acquired by Amazon in 2008, and we started to move on to the platform and their ecosystem then. We are also the largest producer and retailer of audiobooks in the world. We have a collection of over 450,000 different types of audio content. Most of that books, of course, but we also have things, shorter form content like channels or periodic content. Our content ranges across a multitude of different languages, including English, German, French, Japanese, Spanish, Italian. I think I even saw like 12 books in Danish the other day, which seemed interesting in checking out. Seemed like it'd be very like Viking focused or something. It'd be cool. There we go. So that takes us sort of to our mission itself. So one of the reasons I love working at Audible, and really what gets me excited about it, is we're a very mission-focused company. And our mission itself is to unleash the power of the spoken word. And that really includes the entire world and across all of these different devices and places that you might want to listen. Because of that mission, we have very active and engaged customers. That's sort of why I asked how many of you had actually used Audible before, and I'm glad to see so many. You are all awesome and super engaged with us. Our members listened to almost 3 billion hours of audio in 2017. I think this year we're on track to surpass 5 billion. And the average listening time is over an hour and a half, which compared to other sort of digital media companies is actually much higher. So our customers are choosing to spend a lot of their time with us. And so we want to make sure that we are returning our end of the bargain and making sure that our systems are reliable, durable, and that people can actually listen to their books when they want to. So that brings us to the story I wanted to tell about some of our systems themselves, and specifically around content delivery, which, being something that I own, is near and dear to my heart. But it's also a very fundamental and important part of Audible, right? So I think, again, you saw this kind of in the keynote today, but these systems, as they grow over time, you start adding more and more pieces to them, and they become more and more complex, right? You eventually get to the point where no one can really understand the entirety of how they work. You may have a bunch of sequence flow diagrams and block diagrams and stuff up on your wiki, but you're probably missing pieces there, and really no one knows the entirety of them. You've got all of these interactions between the different components. These lead to unpredictable behavior. When real-world events happen, your customers do things that you weren't anticipating. Unexpected things happen and your systems start to break, right? And so what we came to realize was that our systems are already chaotic. It's just a matter of kind of acknowledging that before your customers do. So let me walk through a very simplified case of how our download system works. I basically pulled this together from one of our architecture diagrams. This is, again, a highly simplified view of it. Each of these blocks represents multiple different microservices and components. But it gives you an overall idea of something that seems relatively simple, but turns out to be highly chaotic. So the way this works is when a client device, let's say an iPhone, wants to download, they make a request to get a download link from our content delivery engine. They'll get static metadata for the content. That content delivery service is where the content actually gets served from. It gets a bunch of audio files off of S3, calls our download service to do a bunch of rights checks to make sure that you're actually allowed to access and listen to that content. We also do, these ownership checks themselves are done against a database. And then we also check a Dynamo table to get things like listening statistics and progress of listening for the book as you're downloading it. There we go. All right, so before I talk about sort of how that broke down, a very quick refresher on like microservices 101, right? So in a service-oriented architecture, you've got a whole bunch of different services. If you're doing things well, each one does one thing and does that very well, right? You're distributing the responsibility across all of these different services. So in this case, you may have 4 services or so. You've got service A, it calls B to get some information. B ends up calling C. B also calls D. C also calls D. And so you see how this very quickly sort of spirals out of control, right? So for us, we've got hundreds of these services across all of the different capabilities and feature sets that we have. One of them specifically powers this set of curated books on the homepage. It's one of the most highly accessed ones because it's the main place that our customers land when they're coming to Audible. And so when this service isn't available, we don't want to just give a 500 fail whale type of page. We want to gracefully degrade the experience, right? So we either want to show some other content or perhaps just hide this module and show everything else. We want our customers to still be able to do what they care about, which is find a great book and be able to start listening to it. We don't want to stand in the way of that. So in this example, let's say that was service B. That's the curated summary service. It's experiencing some high load right now, or maybe we just deployed it and has some regression in it. And so the way this should work is that service A detects this outage and instead goes to service C, gets different information. C can then detect that, go to D. And basically, we're degrading the experience gracefully, right? Showing different content. So let's take this back sort of to what actually matters to our customers, right? We always like to sort of take this approach of what we call working backward, where we think about the benefit to the customer first. So what our customers really want to be able to do is buy a book, start listening to it as quickly as possible. Everything else is sort of just another step in the process. Any friction there just slows them down and prevents them from doing what they actually care about with Audible. They want to immediately be able to start downloading. They want to get to this player screen and be able to listen to it. They don't want to see this screen, especially with the some random error code here. And they definitely don't want to see this screen if it's not something core to the download system that is broken, right? If our curated summary service or listening stats or something is down, we should be able to handle that gracefully, and our systems should be resilient to that type of outage and still enable this core experience rather than just failing. So let's go back to this diagram. When everything's working, it looks like this, or at least that's how we understood it to work. This is how every diagram and document we had explained this working. This is how all of our senior engineers and architects knew that it worked. What we realized one day was that we forgot there's a little piece. There is an XML file that lives up on S3. It includes chapter information for the books. So basically a table of contents of each different chapter, the name of it, and the position within the audio that chapter happens. This fetching of the file actually happens after we get all the audio assets from S3, after we do all the rights checks, and after we access both of these databases. So when that file is not there, we end up failing the entire thing with a 500 because we weren't handling it gracefully. We expected it would always be there because it always had been there in the past. Because we're returning just a general 500 error, our clients don't actually know what to do with that. So they do what any self-respecting client would do, which is, of course, retry again and again and again. So this ends up stressing the entire system. To make it even worse, because of that ordering of the logic here, we're accessing both of the databases, getting the file, checking the XML file again and again and again, and failing each time. So we're putting a huge load across this entire system. All of the services and the databases are basically going to get locked up because of this. Customers then, even after all of those sort of implicit retries happen in the apps, customers just see this general error message. They do what every customer, including myself, would do. Don't read the message, hit OK immediately to get rid of it, hit the play button again, and basically retry storm us until everything just fails over. So that is what brought us to chaos engineering. That case of unexpected complexity and chaos within the system is why we started exploring this in the first place. And so what we realized is, like I said, this is still a very simplified view of the download system. And we realized that we're never going to know how the entire thing works. It's just unrealistic to expect that any one person could know it, even that entire teams would, and that our documentation would ever be able to be 100% accurate and up to date. We're never going to understand every aspect of all of the interactions between these pieces. We're never going to anticipate every single thing that our customers can do. And so instead of that, rather than just trying to keep up with this moving train, what we realized is we need to just embrace the chaos, accept the fact that some things are going to break that we're never going to understand at all. Because otherwise, we're accepting the fact that these things will break often at 2 a.m. in the morning and you get paged, and that our customers are going to find these problems for us before we do. So we decided to be more proactive about this and start looking for the chaos ourselves rather than relying on our customers finding it for us. And so chaos engineering really is just a tool or set of tools, framework that is used to gain confidence in understanding of the system. And so we'll talk a little bit more about how to actually apply those tools and frameworks. So before I get into that, a little bit of remedial testing methodology. I'm sure this is very basic for everyone, but I just wanted to set you up with it. So everyone knows how unit testing works, right? Hopefully, everybody is already doing this. If you're not, please go find your nearest exit and go start writing some tests now. It's the easiest thing you can do. But it'll help you, or what its goal is to help you test at the component or module level. So here we're providing some input to a given component, and we're verifying the output against what we expect for that output, right? And so this assumes that we actually know the behavior of the system for any given input, right? So then we move up kind of to the next level, integration testing, very similar. It's just now we're testing at the system or service level rather than component level. But we're still testing knowns here. We have no ability to test things that we don't know about or things that we don't anticipate. And that is where we start to bring chaos engineering into the fold. So with chaos engineering, we no longer call it testing, we call it experimenting. And that's because we're using a lot of the same fundamental technologies and tools that you would use in like a scientific experiment. So here we're experimenting on the system itself to discover the unknowns, gain confidence in the system, and how it's actually behaving. We're taking those scientific experiment methodologies, we're forming a hypothesis, and then we're running these experiments to verify the accuracy of that hypothesis when it comes to our system itself. The way that we do that is by using behavior like purposefully failing calls between different services, introducing latency, network loss, or forcing resource issues like stealing a bunch of the CPU in order to see how the system actually behaves under those situations. And so all of these types of testing are important. I don't want to denigrate anything about unit testing or integration testing. We should be doing those things. They're a very important and core part of your test strategy. But chaos experimentation is really just another way to sort of build on top of that and get more a better understanding of the system itself and more confidence in the behavior of that system. And so this doesn't just apply to media companies like Audible, right? I think a lot of people sort of in other industries like healthcare, financial industry, transportation, they look at their systems and they say these are very critical systems. If we screw something up, people could get hurt, money can get lost. We don't want that to happen, and so they're very risk adverse about embracing chaos engineering. But I think to that, you really have to ask yourself, what is the risk by not doing it? If you're not doing chaos engineering, you may be accepting the fact that your customers or users of the system are going to be the ones that are finding those problems for you. And so even if you are in a mission-critical industry like that, it really is a valuable tool for you to be able to determine these things much faster in a more controlled, safe environment where you're able to actually respond to them and to respond to what you find about your system and make improvements as a result of that. So I think you should absolutely do that. And if you think about it, really, this type of experimentation began in the health industry anyway. This is basically how we run clinical tests and studies in the healthcare industry. So the way that we sort of got into implementing it itself, come on. There we go. All right. Is sort of following this approach of starting off small, doing things manually, getting the support that you need first, and then building up, running this more regularly, automating things, and increasing the frequency of these experiments over time. So where we started was to begin by getting support and help in running these experiments, right? I think one of the things that we had tried to originally do was just start running these because, like you'll probably do when you leave here all excited and pumped up about chaos engineering, we wanted to start running our first experiments, but we realized that we couldn't just do it alone. We needed the support from the rest of our business, from other engineering teams, to really actually be able to do these things. And so in order to do that, this is where we sort of started getting other teams more aware of the fact that we had this much chaos in our system. We were probably just not aware of it. And so the best way to do that is to admit that nobody, yourself included, is going to understand the entire system, that the chaos is going to find you one way or the other. And the best thing to do is be proactive and find it yourself. So this is where you want to work with your business, get the support. Don't try to do it alone. And what we found the best way to actually get that support was to use some of the recent issues that we had, large-scale outages, sort of use our normal process where we go back and look to correct our errors, and use that as a way to show how we could have detected these problems earlier, how we could have prevented them before it caused pain and impact to our customers, and use that as a way to get this buy-in support and make sure that we were actually prioritizing these things. And so we also then sort of looked back and tried to find examples of places where this behavior was arising and how chaos experiments, if designed properly, would have been able to identify and prevent these things for us. So once we had that, we actually went back and, as we were designing our first experiment, we went back and started looking at some of the tooling out there, and we actually found that we had been doing chaos engineering in some regard or another since 2012, which is, I think, actually before it was even called chaos engineering. We had been running a CPU hog experiment as part of our quarterly game days. We just sort of forgot about it, and it was being done automatically. But we really weren't getting that much of a benefit from it because we weren't regularly looking at it. So we already sort of had a lot of the tools and framework in place, but we had never really prioritized running more of these experiments or started designing more complex and useful ones. And so when we had this download issue, when our customers were unable to download for a pretty substantial amount of time because of it, what we did was, for every outage like that, we have a process where we go, we look at what the root causes of that problem was. Not to find any type of blame or figure out who the developer who checked in the specific code that broke something was, but really to find how we can improve our processes, how we can improve our tools, methodologies, and really automate things so that we can prevent the same thing from ever happening again. What type of safety gates or checks can we put in the way to prevent that from happening? And so as part of that process, when we had this issue, we went back and we found that the architecture and the complexity of this system were way more than we thought. And so we used that, again, as a way to get this support and from our leadership and make sure that we were running these experiments more frequently so that we could prevent this type of issue from happening again. And so that's when we started designing our first set of experiments around file issues, so things like the file system disappearing, files just not being there, files being locked up, and things like that. Things that we weren't actively testing for as part of our unit or integration test suite. And that's really what sort of introduced us and brought us down this path in the first place. So what we learned from that, and sort of the approach that we discovered as part of that, was to start by defining what the steady state of your system is. So one of the things that I find when I talk to people about this is that a lot of people feel like there is no steady state for their system, right? Your system's always growing, your company is constantly growing, things are changing every day. That's fine. You don't have to get it 100% right. Sort of the whole point of what I've been talking about is that you're never going to get it 100% right. That's why you have this experimentation framework. But by at least starting sort of with what you do know, that'll show you where you sort of have some of the gaps and give you a good starting place to understand what some of the more valuable different types of experiments may be. So start with how your users actually interact with your system. What are the core pieces of it to them? Look at what the different dependencies between your system and others are, what all of the different microservices may be, how things are interacting there, because it's often those interaction points where most of this complexity arises. And then another good tip for this is you don't always have to start with your most critical services, right? You want to start off kind of small scale. Your point here is not to just go out and cause a massive outage at the beginning. You want to start with a smaller blast radius. And so it's OK to begin some of these with your non-critical services. You can do things in a QA or test environment. That'll help you sort of gain confidence in your ability to actually run these experiments before you're doing it more large scale. Eventually, you do, however, want to get to the point where you're running these experiments in production. You're only ever going to find all of the real issues in production with your real users because, again, they're the ones who are going to do things that you're not anticipating. So you're eventually going to get there, but we'll talk about how to sort of build confidence first and automate things before you necessarily have to do that. You also don't want to force testing on, especially on other teams that aren't ready for it. So start with your own services or your friendly team that sits next to you, someone else who's just as excited about embracing chaos engineering as you are, and use that goodwill to begin with this. Communicate it widely, get approval from these other teams, get approval even from other teams that you don't think you're going to be impacting, because one of the things we found was if we weren't telling people, then things would get blown up when we started running these, and they'd be very unhappy, and we'd be several steps back in our embracing of chaos experimentation, and sort of had to start over again because we had lost some of that trust. So make sure you're proactively getting that trust first. Eventually, you want to get it to the point where you are able to run these things when people are not necessarily expecting it or when you haven't communicated it to everyone. One of the things that we also found was that the more often, as we were running these, if we were giving everyone a heads up, teams started actually changing their behavior, which made some of the experiments less valuable. So they would stop doing deployments right before some of these experiments would run. And just do things that sort of negated the actual results of the experiment. And so by doing it a little bit more randomly or with less notice, we'll actually often find more things than we would otherwise. But again, you don't have to start there. And another good way to sort of minimize some of the risk here is to use the concept of user canaries, which is where you're exposing an experience to some small subset of your users, and then you can measure the impact just on them and reduce the blast radius just to them rather than affecting all of your customers at once. You can also kind of pair this with different deployment mechanisms like canary deployments or blue-green ones, where you're only going to a subset of your hosts or hardware, which will, again, kind of help you minimize that blast radius. So at this phase, this is where you want to take very little risk. The worst thing you can do here is cause a massive outage and lose all of the credibility and trust that you've built up, right? This is where you want to start earning the trust of everybody else. All right, so a good way to sort of think about designing these experiments is to start by looking at what actually makes your customers happy or what they care about. Think about what the primary experience is for your customers or the primary experience that your team is responsible for providing to your customers, and work backward from there. I think it's very easy to lose sight of your customers and users as part of this. We're doing this experimentation for their benefit. We're not just doing this because it's fun to break things and blow things up. We're doing this so that we can make the entire system more resilient, more durable, and make sure that we're always providing that best experience for them. So keep that in mind and kind of work backward from there. And that brings us to monitoring. So once you've figured out what that core experience is and what the things that matter most to your users are, those are where you're going to start developing some of your metrics, right? And so you want to make sure that you're never testing something that you're not prepared to monitor or immediately be able to fix. So the way that we kind of approached this was by looking at the most important things for each of our different teams, right? So for my team, for us, since we own the playback, the most important thing for us is that customers can actually start playing back. And so we measure that by playback start events per second. And so we've got a metric for that, and that's what we use as we're running these experiments. So if we cause any degradation to that, we know we have fundamentally broken the experience, and we will immediately stop this experiment. Just to give a couple of other ideas, some of the other key metrics that I've seen teams build around, our ordering team looks at things like adds to cart, orders per second, or OPS. Our acquisition team uses trial take rates, membership sign-up transactions. I've also seen our accounts team track sign-ins per minute, order cancellations, credit card failures. And then my team itself, even though our core one is those playback starts per second, we also look at things like listening minutes per session, buffering rates, and errors, because those are sort of secondary but key metrics to our experience. And so really the most important thing to know if you've got the right metric here is if that metric is healthy, it should mean that your entire system is generally healthy, or at least that your customers are able to do what they care most about. Conversely, if that metric dives down, you know that your experience is broken for your users, and you need to take immediate action for that, right? So you may have other services that don't directly impact these metrics, and those are, of course, important to you, and you should make sure that they're not just broken all the time, but they're not as critical to the rest of your experience. Once we knew what that metric was, we then started monitoring this as part of the experiments. It's OK to watch this manually at first. You don't have to automate everything about this. But basically, you've now got your dashboards and graphs and things, and you can watch those as part of the experiment to know if things are going well. All right, so then that brings you to running your first experiment. You've got everything in place, right? And so you can start off really small and easy. One good example here is basically just log into one of your hosts, kill the process of one of the servers, and if things are as resilient as they should be in a distributed microservice architecture, that really shouldn't have any impact on anything, right? I think if you actually go and do this, though, you may find something very different, right? And so what makes this a good initial experiment is kind of a couple things. One, it's obviously very easy to do. You don't need a whole bunch of complex tooling and frameworks and things to do this. You can go do it manually yourself, probably in 10 seconds. But it can also be started and stopped very quickly and easily by hand. And so if you do this and things break, you should be able to start the process back up pretty quickly, or something may already be like restarting it automatically for you if you've got the right tools in place. And that means that you'll even if things go really badly, you won't impact your customers for a very long time. You'll be able to sort of bring back the experience pretty quickly. This also will allow you to test out your metrics and monitors, make sure that all of that stuff is correct. And it'll make sure that you can actually run your experiments in a controlled way. So as you're figuring out this first set to do, another kind of tenet to keep in mind is targeted chaos. And so really the core thing to remember here is don't harm other teams and don't harm your customers if it can be avoided here. Again, you want to show that chaos can work without disruption to your normal processes. You want to show that it provides value because you're able to detect issues. And so you're still doing experiments manually here, likely within your own team or like I said, a kind of willing volunteer. You want to minimize the blast radius here. You're not just breaking things to break them. You're validating against your hypothesis. And you can seek inspiration from other recent issues here. All right, so after you've sort of got all of this foundational stuff in place, this is where you want to start going a little bit more complex and start affecting things that may go outside of your own team. This is where it's very important to start first with a hypothesis about how the system actually behaves. And so this hypothesis should be something that is measurable with the KPI or those key metrics that you've defined already. Because you want to be able to see very quickly if that hypothesis holds true or not, and be able to learn and adjust from that, right? So for us, one of the hypotheses that we began with was that reporting listening statistics would not affect our ability to actually start playback for customers. As you're listening, we report all of this session-based data around how long you've listened, what device you're on, things like that. The ability to do that should not prevent anyone from actually being able to listen to something, right? That's all just sort of background data. And so we believe that, but we also suspected that our system probably wasn't as resilient as we thought. And so we wanted to actually run this experiment to see if that held true or not. So you can start with something like that. And again, this is a place where you're now going to start impacting perhaps other teams. You're going to be measuring against your key metrics. And you're making sure that not only your team has the right metrics, resiliency and alarms, but that the other teams around you sort of do too. OK, and so a couple of ideas just to give you inspiration here. One is adding latency between the calls across your systems, whether that's from your website to the services, services to database, services to services. Just start injecting additional latency there. You can also make services and/or their dependencies unavailable. You can inject exceptions into arbitrary points of your code, see how your services actually handle that. You can actually do things like simulating packet loss, dropping requests, or just failing them. And you can start to add resource contention things too. All of these are fairly easy to start implementing, but you'll learn a lot from them because they're often things that we don't think a whole lot about, especially since a lot of the more infrastructural stuff is taken care of us as part of microservices architecture. All right, so once you've got an idea of what those experiments you want to run are, this is where you want to start getting a little bit more sophisticated. And so you want to have a framework for this stuff. You don't want to be running these manually every day. It's going to very quickly become more than you can do as part of your day job. And so there's some great tools out there. The one that we use internally is called Gremlin. Gremlin is actually a phenomenal partner in the space of chaos engineering. They're here. They've done a couple of talks too. You should absolutely check them out. They're at the expo too. They're great friends of ours, and we love them. Not a sales pitch for them, just very, very happy to be sort of working with them on this stuff. But anyway, the tool itself actually doesn't matter as much as some of the capabilities for it do. So what we love about this tool that we've got is that it gives us a great front end for running a lot of this stuff where we don't actually have to think about it. And so as we started automating these things, you'll see here, this is just one example of them, but this is a place where we're running an experiment against our fulfillment service, where we're generating 80% CPU load against 6 of the hosts in that fleet. What makes this tool so great is it's got all these different powerful types of experiments, or what they call attacks, that you can run. I'm only listing them just to give you an idea of what some of the different ones are. But basically, you can do things like adding things between your dependencies. So you can add latency or packet loss to requests to your downstream dependencies. You've got host class ones where you can add latency or packet loss to all requests to a given host class, which is a great way to sort of block out an entire set of dependencies. You've got network level ones where you can add latency across the network. You can do things like blocking DNS resolution, dropping traffic to specific ports, simulating VIP moves or drops. Again, all things that you probably don't really think about a lot in your sort of daily development or operation life, right? But a lot of times our systems, because we don't think of those things, are not as resilient to these as we would think. You've also got service level ones where you can simulate things like a slow consumer. You can just kill processes directly. You can send various signals to them, like sig stops. You can issue a kernel panic, which is a especially nasty and favorite one of mine. You can write phrases to your logs to see if your log scanning tools are actually working the way that they're supposed to be. You can introduce host resource issues like hogging the CPU, memory, the disk itself. You can put the file system into read-only mode. You can reboot the hosts. You can hog up the IOPS. You can cause an entropy drain. All of these nasty things that really, a lot of cases, our systems are not designed that well around, right? And so you'll learn a lot about how your system actually handles these and sort of make it a lot more robust in the process. And then lastly, you can do things in the code itself. They call these injectors. This is where you are throwing exceptions within your code or injecting latency sort of at the individual line of code level. And so again, the specific tool or framework you use is probably not as important. Some are more powerful than others. But the important things that you want to make sure you have as part of it are this web UI where you can run and configure all of these experiments. You should be able to control them and monitor them from there. You don't want to be jumping between 10 different tools and SSHing into hosts and things as you're running these experiments. Because if things start breaking, that's really the last thing you want to be manually doing. Being able to see everything together really helps a lot with that. You also want to make sure that it's got a service layer injection framework. That's where you're going to be able to do these things like exceptions and latency within your code. And then it should have a host agent that just runs on your host itself. That's what's going to be able to do like these CPU load attacks and things like that. And so I mentioned already that this injection framework is a really important piece of this, and something that you may you can use an external tool, but it's also something you can fairly easily do yourself. It's fairly simple. Basically, the concept is just you've got this injector, which is a library or module that you can inject into the code of your services. It'll intercept things like your service calls, and based on the configuration or the state of the experiment, it's going to add latency or failures there. And so what ours looks like is sort of like this. We've got this great proxy, which is Spring compatible. It integrates into like our internal service orchestration libraries, and basically just gives us an annotation that we can use and a little wrapper that we can put around our client callers that go from one service or client to another. And so when the experiment's not running, that just short circuits, doesn't do anything. When the experiment is running, it'll do whatever logic is required to actually run that experiment. All right, so now let's go back to this issue, right? So like I said, what we learned from this and what we do differently now is instead of just adding another unit test now where we test if whether or not this file is there, sorry, how the system responds if that file is not there, we now run chaos experiments around this entire system. And so we'll block connections between each of these different services here. We'll block connections to S3. We'll add latency across each of these different components now. And basically making sure that this entire end-to-end system can handle all of those things so that we don't have a similar outage again. All right, so again, once you sort of have run a few of those experiments, this is the part where you really want to start automating everything, right? You don't want to have to continuously configure these things yourself, so you don't want to have to be the one hitting the button to start and stop these things all the time. You want this stuff to really become part of your normal day-to-day operations, sort of the same way that you're doing the other types of testing. You don't really have to think about your unit tests most of the time, right? They run as part of your normal build cycle. They hopefully run when you check your commits in, and run before any deployments happen. And you want to start running these experiments in sort of the same fashion. And so before you can do that, you need to understand what your maximum acceptable impact you can actually have to your users is. And so again, we want to use our key metric itself to define that, but we want to understand like what the maximum impact of that is going to be as part of these experiments. We don't want to just affect everybody again, right? And so for large companies like ours, or ones with a lot of users, this can be a lot easier. If you have a lot of users, it's very easy to get a lot of meaningful data from something as small as 1 or 2% of traffic, right? But it can be a lot harder for smaller companies or teams building internal tools where you've got a small set. And so I think something that helps there is you can look at the way that you're sort of currently running. How are you treating your metrics and monitors in the first place? How much impact are you sort of already accepting to your customers? And sort of work backward from there. And so the way that we decided how to do this was to look at the way that our monitors were configured and how we were acting on our issues in the first place. And so we found that in most cases, we were only looking at typically 98, 99% of our traffic and the latency there. And so we weren't really doing that much to act sort of on the highest 1% of latency or traffic. And so we chose 1% as our maximum acceptable impact because we were sort of already living in that world. So ideally, Initially, a lot of the other teams had resistance to the fact that we'd be running these experiments even on 1% of our customers. But so the way that we sort of turned that around was to show that with this experimentation, we're actually providing a much better experience not only to the other 90%, but also to these 1% over time as well, right? So we're using this 1% as a way to test against these hypotheses, but we're also using this as a way to make our system more robust and durable over time, which is going to benefit 100% of our customers. And so sort of looking at it that way turned the conversation a little bit more around, and got past some of that hesitation and resistance. And so the way that we actually use this number with our metric and as we're running these experiments is that the system will spin up both a control and experiment cluster. It's all the same code, but basically mirrored environments of each other. And the experiment cluster is the one where we're actually running the experiment. And so the system will then route traffic in these proportions to each of those different clusters based off of that. The system then monitors the metric itself. If it breaches the maximum acceptable threshold, we cut off traffic to that experiment, stop running the experiment. It cuts us a ticket, because a lot of times this is running at night or kind of off hours. We have then stopped any impact to our customers, and we can respond to that ticket the next day in the office when everyone's around and not half asleep, and not getting paged in the middle of the night. And so that gives us time to figure out the problem during our actual work hours, and not in the middle of the night. And so what that looks like in practice is something sort of like this. You've got your client, which hits the load balancer. Your chaos automation framework will handle the routing of the traffic to each of these different clusters. So you've got your normal production one, you've got your control one, and then you've got your experiment one. I think the somewhat confusing thing here is, or what I get asked a lot is, why do you need a control one when it's basically the same thing as your production one? And so what we found was that if you're routing 1% of traffic to experiment and 99% to another one, your results are not always going to be that valid, because you'll have differences as a result of those different traffic patterns. You may end up with that 1% of traffic you're randomly selecting may not be representative of normal traffic. And so by having a true kind of apples to apples comparison between the control and the experiment cluster, you're going to have a lot more valid results. Another important thing to note here is here we're talking about production, right? These are real customers that we're talking about. This is not our development or pre-production environment. We're doing that again so that because we're only going to find these things because our real customers are doing things that we don't expect. But we've done all of those other things already that we've talked about to make sure that we have limited risk by doing this, and that the system can automatically handle any impact that happens here. And so what it actually looks like as the experiments are running, or sort of what the system is doing, it's looking at that metric, comparing the two different clusters. So in this case, let's say this is error rates, and the orange one is our experiment. The silvery gray one is our control cluster. And so you see, for the most part, they're sort of tracking pretty close to each other, not a huge deviation there. And eventually, as traffic is increasing there, you're starting to see a much higher deviation between them. And so the system will detect that, see that it's breaching that maximum threshold, and immediately cut off traffic to the experiment cluster and stop the experiment there. So once you have that, this is where now you want to start embracing this across the entire organization and running this very, very regularly. You want to run it kind of across all of your teams, run it globally. Like I said before, run it with limited warning so teams aren't cheating in advance of it. You want to run it in production. And you also want to run it very often. So I think one thing people may not realize with this is that the results of these experiments sort of has this limited shelf life, right? Your systems are changing so frequently that the results of your experiment are really only valid for the current state of the system. And so if you're now adding new dependencies, new logic flows and things, those results are no longer as valid as they were when they first started. And so you want to make sure that you're repeatedly running this so that you're keeping those results fresh. You also want to make sure that you're getting feedback from other teams and your stakeholders. The entire purpose of this is to make things better than before. So always ask if things actually are better. Are you finding issues now that you weren't before? And is the experience for your users actually better? You also want to use the results of these to really get more support for this and to continuously advance this more widely across the organization. And so make sure you're publicizing the results of these too. celebrate the wins that you've had from this. Look at what you prevented from occurring, what experiences you have made better or more reliable for your users, and what issues you were able to find as part of these experiments that only affected 1% of customers for maybe a few minutes rather than being this massive outage that lasted for hours. So celebrate those things very widely, especially with your business stakeholders and things, because they're then going to start using those examples as things to celebrate as well, and will help you prioritize even more and more of these tests. And conversely, also look at what maybe hasn't gone so well with these. Use the feedback process as a way to see what you could be doing better with this. Use that as a way to see how you could maybe be designing more intelligent experiments, and make sure that you're constantly improving over time as well. And then also look at what issues you found that you wouldn't have found with your normal set of unit and integration tests before, because those are the real value that you're getting out of this. Those things that you couldn't have found because you didn't know about them before. And so some of the things that we learned as part of this were that a lot of other organizations across the industry, they'll have separate teams that are doing this, right? Or often it'll be part of their operations or infrastructure teams that will own these experimentation frameworks. We decided to do it within our development teams. It was sort of a decision we made because we felt it would add more accountability to our teams and really kind of improve the overall engineering maturity of the team. And we found that to be very generally true. Another thing that we learned was that it was very difficult initially to prioritize the creation of these experiments. There was just always something more high priority to build. We're always adding new features and focusing on growing. And so it was often hard to sort of get the time to actually do these experiments. And so, like I said, what really kind of changed the conversation there was using our corrective action process, root cause analysis, to demonstrate how our existing tests were insufficient and how chaos experiments would be able to prevent and detect these issues earlier. We also learned that publicizing results very widely, especially to leadership, when we found and prevented an issue, got us a lot more support for this and sort of got us a lot more brownie points. We also learned that it was useful to build our own framework for automating the injection of failure into our systems, especially in our service APIs. And we instituted this as a sort of automatic process or core part of how we build new services, so that any new developer or anyone building a new service would sort of get these frameworks for free and not have to remember to set them up or configure them or anything. Now, as we build new services, they're just there, and so it makes all of our experiments even more valuable and sort of easier to run. So implement this as part of your sort of normal development process as well. We also identified multiple cases where an unintended consequence would have arisen from changes that we were making and potentially caused a massive cascading failure. By running these experiments, even some of the more simple ones, we were able to find those things much earlier on in the process and adapt to those before it was affecting a large part of our user base. And we also solved a long-standing issue with our streaming service, which was encountering issues every time a downstream service was deployed that we actually didn't even know was happening and was impacting our customers. But because it was impacting a small subset of them, we were never detecting it. And these experiments actually uncovered that for us, and we were able to fix it and make that experience much better. So things that I'm hoping you take away from this are that every organization can and should be doing chaos engineering. You've already got the chaos there in your systems, no matter how big, how small, how mission critical, what industry you're in. That chaos is there, and it's better for you to understand it. You should also take away that the process of implementing chaos engineering itself helps inform teams much better about their systems and instills best practices that otherwise they may not have had. Keep in mind that the core tenet here, again, is not to do harm to the customer. I think too often people get all excited about chaos engineering, and they just go out and try to blow up as much as they can. Sure, you'll learn some things from that, but you'll learn a lot more if you're being very targeted and smart about how you're building your hypotheses for this. So always remember that the point of doing this is for the benefit of your customer, not to just break things for them. And then don't run it alone. You get support from your business and other teams. They'll help you. They'll become your biggest advocates the more you do these things. They'll sing the praises of this and help you get the support that you actually need for it. And then lastly, remember that chaos engineering does not cause problems. It reveals them. Use these tools and methodologies as a way to find these problems rather than just blowing things up. If you're interested in learning more, again, like I said, I'm very happy to talk to you over social media, email, however you want to get in touch. There are a couple of related talks. I know they're in the past, but you can find the recordings for them. They should be up on YouTube either very soon, or they may actually be up already. Some great real-world use cases here on how other organizations improve their reliability and scalability. So you can learn a lot from there. And then lastly, I just want to say thank you for coming out of here again. I was very happy to see all of the super happy Audible customers here. I appreciate that it's a very long week. There's a lot of great talks going on. And so thank you for coming here, one of the overflow sessions. I hope this was useful, whether this was the first year ever hearing of chaos engineering, or if you've been doing a little bit and just wanted to get a little bit more into it. And again, in either case, I'm very happy to share some more of our experiences and help connect you with any resources if you need. So those are the best ways to get in touch with me. And then lastly, please complete the session survey in the mobile app. It's the only way that we get feedback and know what was useful, what wasn't, what we should change, what we can do better. And we definitely read every single one of those comments and parts of feedback. So if it was great, very happy to hear that. If there are things that could be better, super happy to hear that too. So thanks again, and go out, spread the chaos, and learn from it.